Hello children, this lecture we will start from the heading Explanation for Low Reactivity of Aryl Halides. Okay children, so what is the main reasons which are responsible for the low reactivity of aryl halides? We will start our this discussion from this heading only. Okay, so there are number of factors for this, and in those factors the first one is resonance effect. So as you can see here, uh, aryl halides are the resonance hybrid of the number of structures. Okay, number of canonical structures or resonating structures. Such type of resonating effect is not seen in alkyl halides like CS3X or C2H5X. Okay, so due to this resonating effect, the aryl halides are comparatively more stable than alkyl halides, and that is why the energy of activation of alkyl halides is less than the aryl halides. Energy of activation of aryl halides is comparatively more, and that is why these are less reactive. Okay children, so if you want to draw the resonating structures of any aryl halide like bromohalide, bromobenzene, so this is a molecule of bromobenzene, and you know that halogen which is present here will have 3 lone pair of electrons. So out of these 3, 1 electron pair will delocalize in this way here. So you will get the first structure, okay, with positive charge here, and double bond. So when this will evolve here, then this will delocalize in this way. Okay, so this bond will be shifted in the form of negative charge here. Okay children, in the next structure, this negative charge will delocalize here and this will shift it to here. So this site will be negatively charged, double bond, this is double bond Br with positive charge. Okay, in next structure, this negative charge will delocalize here and this will here. So negative charge will shifted here, double bond Br with positive charge. Okay, and in last this will shift here and these pi electrons will delocalize towards bromine atom. So bromine with 3 lone pair, double bond, and at last this is the hybrid structure, resonance hybrid of these all structures. Okay children, so in this way you can draw different resonating forms of aryl halides. Okay, the next point for the low reactivity of aryl halides, Cx bond length. Okay, so Cx bond length in aryl halide is comparatively less than in alkyl halides. Okay, and less bond length, more bond strength, and more bond dissociation energy. Okay, so due to more bond dissociation energy, aryl halides are comparatively less reactive than alkyl halides. The next point, energy of activation. So energy of activation of replacement of halogen atom in aryl halide is greater than alkyl halides. Okay, the next point, different hybridization state of carbon atom holding the halogen atom. So in the case of alkyl halides, this carbon atom which is holding this halogen is sp3 hybridized, and in aryl halides the carbon atom which is holding halogen is sp2 hybridized. So sp2 carbon due to more electronegative in nature, and that is why the Cx bond in aryl halides will be shorter than in alkyl halides. Okay children, and that is why the bond strength of Cx bond in aryl halides will be more than alkyl halides, and due to greater electronegativity of carbon atom in aryl halides, the carbon halogen bonds, in carbon halogen bonds, the electron pair will be strongly held by this carbon atom. Okay, and that is why the bond strength will be more and there will be less reactivity of this bond in aryl halides. Okay children, then polarity of Cx bond. In the case of aryl halides, the Cx bond is comparatively less polar, and due to less polarity, the reactivity of Cx bond in aryl halides is also less. Okay children, and according to this last point, due to possible repulsion, it is less likely for the electron-rich nucleophiles to approach electron-rich arenes. Okay, because in arenes, electrons are present in the form of pi electrons of the benzene ring. Okay, so due to the presence of excess electrons in the form of pi electrons, there will be a repulsion between these pi electrons which are present in benzene ring and between incoming nucleophiles. Okay, because both are electron rich units. So due to this repulsion between incoming nucleophiles and pi electrons of benzene ring, the replacement of halogen atom from aryl halides will be little bit harder than the alkyl halides. Okay children, next, chemical properties of haloarenes. So first, nucleophilic substitution reaction is replacement by hydroxyl group. In this reaction, halogen atom of aryl halide get displaced by hydroxy group. So for this reaction, as a reagent, we use aqueous sodium hydroxide, and when this aqueous sodium hydroxide react with aryl halide, then first sodium phenoxide is formed, and when this sodium phenoxide is acidified with the help of dilute acid, then it get converted in the form of phenol. So this conversion from aryl halides to phenol is known as Dow's process. Okay, so in Dow's process, chlorobenzene is get converted in the form of phenol. Next reaction is replacement by amino group. So in such conversion, haloarenes converted in the form of aniline. Okay, so halogen atom is get displaced by NH2 group. So when haloarenes react with aqueous ammonia and cuprous oxide, then aniline is formed. Next, displacement by cyano group. So in this reaction, halogen atom of aryl halide displaced by cyano group. Okay, so reagent which are using here is cuprous cyanide, and in the presence of dimethyl formide, okay, dimethyl, in the presence of dimethyl formide. So this reaction is taking place in the presence of dimethyl formide. Okay, so formation of cyanobenzene is taking place, or phenyl cyanide is taking place. So as we have already discussed in the case of alkyl cyanide, here also this cyano group can be converted in the form of different groups. On reduction, this cyano group converted in the form of primary amine group. On complete hydrolysis, the cyano group will be converted in the form of acidic group, and on partial hydrolysis, the cyano group can be converted in the form of amide group. Okay, children. Then reaction with sodamide in liquid ammonia. With the help of this reaction also, we can convert aryl halides in the form of aniline. Okay, halogen atom displaced by amino group. Then next heading, a reaction with metals. So this reaction we have already discussed here. In short, first reaction is Woods fitting reaction. So under this heading, we used aryl halides, two molecules. Sorry, Woods fitting reaction, we use aryl halides with alkyl halides and sodium metal in the presence of dry ether. So we get alkyl substituted benzene. Okay, alkyl substituted benzene. So as you can see here, when chlorobenzene is reacted with chloromethane, then toluene is formed. The next is fitting reaction. Fitting reaction, and in this reaction, two haloarenes react with sodium metal in the presence of dry ether. So diphenyl is formed as a product, diphenyl. Okay, then reaction with magnesium. So this reaction also we have discussed already in the case of alkyl halides. When aryl halides react with magnesium, then phenyl magnesium chloride is formed, which is also known as Grignard reagent. Okay, for this conversion we use tetrahydrofuran as a catalyst here. Then reduction, haloarenes can be reduced in the form of benzene in the presence of nickel aluminium alloy and sodium hydroxide. Nickel aluminium alloy and sodium hydroxide. Okay, children. The next heading is electrophilic substitution reactions. Electrophilic substitution reactions, and these substitution reactions are taking place in the presence of electrophile, or you can say that in these reactions substitution is taking place due to the attack of an electrophilic reagent. Okay, so common reactions are here. First is halogenation. So halogenation, with halogen in the presence of anhydrous ferric chloride, which is acting as halogen carrier. So ortho and para dihalide mixture will form. Ortho and para dihalide mixture. Okay. For example, when chlorobenzene is reacted with chlorine, then ortho dichlorobenzene and para dichlorobenzene is formed in the form of mixture. Nitration. Nitration, in electrophilic substitution, this halogen atom is acting as ortho-para directing group. Ortho-para directing group. Okay, because this is an electron donor group, so it will direct incoming electrophile at its ortho and para position. Okay, children. So same here for nitration also. When chlorobenzene is reacting with nitrating mixture, What is nitrating mixture? A mixture of concentrated nitric acid with concentrated sulfuric acid. This is known as mixture of nitration or nitrating mixture. Okay, so chlorobenzene is converted in the form of a mixture of orthonitrochlorobenzene and para-nitrochlorobenzene. Sulfonation with conc H2SO4, orthochlorobenzene sulfonic acid and para-chlorobenzene sulfonic acid is formed as a mixture. Or children, as you can see that in all these conversions, generally para isomer is formed as a major constituent. Para isomer is a major constituent. Last example of electrophilic substitution reaction, and it is Friedel-Crafts reaction. So in this reaction we do alkylation and acylation of aromatic compounds. Alkylation, so on alkylation we introduce an alkyl group in benzene ring, and on acylation we introduce COR group in benzene ring, COR group. So this COR group is known as acyl group, COR. Okay children. So on alkylation, first is alkylation. So for alkylation we can use alkyl halide or alcohol as a reagent. Alkyl halide or alcohol as a reagent. Okay children. So here alkyl halide is used as a reagent. When alkyl halide react with chlorobenzene in the presence of anhydrous aluminum chloride, then we will get a mixture of ortho and para derivative, methyl derivative of chlorobenzene. So orthochlorotoluene and para-chlorotoluene, a mixture is formed. Then in acylation, for acylation we are using acetyl chloride here as a reagent, and orthochloroacetophenone and para-chloroacetophenone. A mixture is formed of these two compounds. Okay, where para substituent is present in major amount. Okay children. So acetyl group, acetylation. Okay, because here this acetyl group is used here, acetyl group, so it is known as acetylation. Under acylation, this reaction is acetylation, because CH3CO, this group is known as acetyl group. Okay, so this is a common group which is known as acyl group, and this acyl, this is acetyl group when CH3 is present here. So this is an example of acylation in which we are introducing acetyl group in benzene ring. Okay children. The next heading is effect of substituents on the reactivity of the halogen atom. Okay children. So when electron withdrawing groups are present at ortho and para position, then electron withdrawing group increases the reactivity of this benzene ring. Okay, this benzene ring reactivity will increase when electron withdrawing group are present at ortho and para position. Okay children, as you can see from here, when any electron withdrawing group is present at para position or ortho position, so out of these resonating structures, as you can see that the carbon atom which is carrying this electron withdrawing group is having a negative charge at one resonating form. Okay, in para position and in ortho position also. Ortho position, this isomer is having, this resonating structure is having here minus charge on this carbon atom. Okay, So due to the presence of this minus charge at the carbon atom, which is having electron withdrawing group attached with it, so due to this form of structure, here this minus charge and these pi electrons both are taking part in the conjugation with this nitro group also. Okay, so dispersal of this minus charge and these pi electrons will continue up to this nitro group also. Okay children, in both the case of para and ortho substituted haloarenes, when they are having electron withdrawing group. Okay, but in the case of meta substituted haloarenes, the carbon with which nitro group is attached, it is not carrying a negative charge in any contributing structure. Okay children, so that is why in meta substituted, this negative charge cannot showing any conjugation with this electron withdrawing group, and that is why meta substituent are comparatively less stable or less reactive for the electrophilic substitution reactions, okay, in comparison to ortho and para substituted compounds. Okay children, thank you.